Now, questions like this are a real favourite of VCE examiners, mainly because they bring together about 2 or 3 different topic areas all together in one question. So fabulous to test people's depth of knowledge. This question, the line y equals mx, never intersects a circle with centre 10, 0 and radius 5. Find all possible m values. Now, the first thing we've got to think about when we think this is it's talking about the intersection of 2 graphs, a circle and a line. Now, whenever you see intersection of graphs, the first thing that should spring to mind is this means the same thing as solving simultaneous equations. So to find the points of intersection, I want to solve simultaneous equations. So the first thing we want to do is get our 2 equations to solve. Now, a circle with centre 10 and radius 5 has the equation, well, it's got a centre of x equals 10, so it's x minus 10 squared. The y centre hasn't moved off the axis. Oops, that's a squared there. And the radius is 5, so you have 25 on that side. So that's your equation 1. The equation we're looking for it to intersect with is y equals mx. So that's your equation 2. Now, we want to solve these simultaneous equations, or at least start the process of solving it, because by solving it we find points of intersection. So now I'm going to sub equation 2 into equation 1. So that's going to give me x minus 10 squared. That doesn't change. Now I'm subbing in whatever is here for y, which is this stuff, into this y squared here. So that's plus, now to be careful, when you sub things, it's best to sub it inside brackets like that. mx all squared equals 25. Now, this is starting to turn into a quadratic with x because I've got some x squareds. To solve a quadratic, I need everything on the left side and nothing on the right side. So to do that, I've got to actually expand these brackets first. So let's expand them. Now, x minus 10 all squared. If you want to, you can write that out as x minus 10, brackets x minus 10. It's good to be able to do the shortcut, which is this is like a minus b all squared, which becomes like a squared minus 2ab, or in this case, minus 20x, plus b squared, which will be 100. Now this next term, when we expand it, don't forget the squared applies to both of the things, so you've got m squared x squared. And I want everything on the left, so I'm going to bring the 25 here onto the left as well. And I want 0 on the right. So this is now in a format where we can start to solve it. Now to make it really look like a quadratic, I want to group my like terms together. So I've got an x squared term here, I've got another one over here, so I'm going to bring them together. So my new coefficient of x squared, if I factorize it out, I get 1 plus m squared, lots of x squared. Think about how you can re-expand these brackets and you'll get the same thing that we started with. How many x's do I have? The only x term I've got is this one, so it's minus 20x. Oops, running out of room there. And I'm going to have plus 75 over here. All right, so that's the equation I want to solve. Let's rewrite that on the next page. So it's 1 plus m squared x squared. What was the next bit? Minus 20x plus 75. Minus 20x plus 75 equals 0. Now, we are told that there are no points of intersection. This is the equation which tells me where the points of intersection are. So if there are no points of intersection, there are no solutions to this equation. Now this is where it brings in the next part of the topic. So if there's no solutions to what is here a quadratic equation because of the x squared, that means the discriminant of this thing must be less than 0. So I want to work out the discriminant of that. And it's time for a new colour. Let's go to green. So the discriminant of this thing is equal to b squared minus 4ac. b is negative 20, so it's negative 20 squared. Again, use brackets. I love brackets. They're very, very useful. It avoids mistakes with the negative. So that's b squared minus 4 times a. a is 1 plus m squared, times c, which is 75. Okay, now let's expand this. Negative 20 all squared becomes 400. Didn't write properly. There we go. 4 times 75 is 300, so I can do that 300 first. 300 multiplied by what's in the brackets gives us minus 300 minus minus 300 m squared. So that's going to simplify to 100 minus 300 m squared. There we go. Or let's even make that simpler for ourselves. We'll call it 100 1 minus 3 m squared. That's not a bad way of going about it as well. All right, now we now need to find when this is less than 0. So we need to find when 100 minus 300 m squared is less than 0. Now, whenever you have something here which is a quadratic still and an inequality, don't try and solve it algebraically. Only try and solve linear things linear inequalities algebraically. For a quadratic one, you really want to graph this. So I want to graph this 100 minus 300 m squared. Now, if we're good at our graphing, we know that this is an upside down parabola. The y-intercept is going to be 100 because of 100. It's a minus m squared, so it's going to be going around something like that. Now this is m. This is the value of the discriminant. Now we're interested when the discriminant is less than 0. So the discriminant is less than 0 in this area of the graph because we're in negative discriminant territory. This is when the discriminant is negative. We're also interested in this area of the graph. So we need to find these intercepts. Now these intercepts, if we let the discriminant equal 0 to find the intercepts, then we're going to get 300 m squared equals 100. If we just move that around a bit, m squared equals a third, or m equals plus or minus, don't forget that when you square root, 1 on root 3, or you can call that plus or minus root 3 on 3 if you want. So that point there is 1 on root 3 comma 0, and that point there is negative 1 on root 3 comma 0. So that the m values that create these sections of the graph that I'm interested in are either m is greater than 1 on root 3, that's this bit, that's sort of all these ones here, or m is less than negative 1 on root 3, that's all these bits over here. And let's just, to wrap this up, have one quick visualization of what that means. If we think back to the original question, we had a circle, center 10, 0, radius 5, something in the order of sort of that. We have this line y equals mx. Y equals mx is a line that goes through the origin and has a gradient. Now it's not allowed to cross this, it's not allowed to touch the circle at all. So here, this one's okay, doesn't touch the circle. This one that goes through here is just a tangent, or they pretend that's a tangent, almost got it. That's the line y equals 1 on root 3x. So you can see that once you get to that gradient, you just touch. As long as the gradient's more than that, you don't touch. Same thing going down here the other way. Whoops, again, almost got it. That's the line y equals negative 1 on root 3x. So as long as the gradient's more negative than that, then you're not going to touch as well. Anything here in the middle is going to intersect the circle twice, in fact. So I hope that's useful. Really important style of question to get useful for all of methods 1, 2, 3, and 4.